And again, we're recording today's program remotely. I'm speaking from my home.
Yes, I can see you're in a different room than last time. That's a beautiful stove.
Thank you. It really keeps us warm in the winter.
Well, let's take a look at today's lineup. On today's Leading Edge, exploring the mechanisms of dreaming. The simple act of dreaming while we sleep has long been full of mystery, with much that was unknown scientifically. Now, the latest research is beginning to yield some new clues. Brain research has offered an explanation for why dreams are easy to forget, and will also introduce some remarkable technology that allows us to peer into a person's brain while they're dreaming. And on J Innovators, our reporter Michelle introduces natural human-type ceramides that play a role in moisturizing human skin and making it an effective barrier. Ceramides are also popular as a cosmetic ingredient, and the Takumi we'll later meet discovered an unusual way to produce them from a very common seasoning in Japanese cuisine. So first, let's begin with the leading edge. Today's topic is exploring the mechanisms of dreaming. Well, dreams are so mysterious. They can be quite bizarre, and a lot of the time we forget what they were about.
Yes, I often dream of flying only to wake up disappointed that I can't, or I forget everything. Sigmund Freud and Carl Jung are known for pioneering scientific research on dreams in the 19th and 20th century. Generally speaking, the approach of depth psychology was that interpreting dreams could help explain the unconscious.
And how did that approach change?
The invention of the electroencephalograph in the mid-20th century enabled great progress in dream research. This helped us discover the special stage of sleep known as REM sleep, when most dreaming occurs.
Yes, I've heard of REM sleep.
Until then, dream research was based on subjective reports made after hearing the dreamer's description. The electroencephalograph and discovery of REM sleep made it possible to study dreams objectively.
But I imagine that even technological progress could lead researchers to completely different conclusions.
Definitely. Some say that dreams are random signals sent by the brain and are completely meaningless. Conversely, others believe the source of dreams is desire, so dreams do have meaning.
Dreaming is still full of mysteries. Let's see how research on dreaming is done.
We visited Dr. Keiko Ogawa's laboratory at Hiroshima University, where she's studying dreams and physiological activity. Ogawa showed us inside.
ここは睡眠実験室になります。
Inside the laboratory is a small, completely soundproof bedroom.
参加者さんにはここに寝ていただいて、で、寝ている最中に起こして夢聴取をしてもらうときに寝たままでこの質問紙に夢の内容を回答してもらいます。
They answer questions about how they're feeling and their dream before going to bed and after waking up. Evaluating with numbers enables dreams to be turned into objective data. A subject participating in the experiment has just arrived. Kanae Suzuki is a student in this lab. Since the experiment takes 7 hours, the lab students often use themselves as guinea pigs. First, it takes an hour to attach about 30 sensors to the head and body. This is to observe movements of the eyes, chin, and heartbeat in addition to the brain waves during sleep. The person in charge of today's experiment is Tomoka Fuchigami, an upperclassmate. The research topic is, can you control your dream? For 3 minutes before going to bed, the subject tries to think about the dream they want to have. What is Suzuki thinking about?
今ちょっと好きなアイドルがいて、ジャニーズの キング&プリンスなんですけど、ちょっとその人について念じようと思います。
ちなみになんか念じる場面とか決まってるんですか？
一緒にお話ししてるところを念じます。
それではおやすみなさい。
The experiment has finally started. Ogawa and her staff pay particular attention to brain waves and eye movements. After a while, changes began to appear. The eyes are moving slowly in a cycle of 3 to 5 seconds. This condition, called slow eye movement, is a sign that non-REM sleep is beginning. REM sleep occurs about 90 minutes later, and most dreaming occurs in this stage. If they miss the moment the subject goes into REM sleep, the experiment will be ruined. The observers wait anxiously.
1時間は寝れるんですけど、やっぱり大変です。
About 90 minutes later,
これですね、レムが来ました。まるで起きてる時のような目の動きっていう状態がレム睡眠になります。
the speed at which the eyes move is suddenly increasing rapidly.
じゃあ起こします。
Woken up by the buzzer, Suzuki immediately starts answering the questionnaire. This is because the contents of the dream will quickly disappear. What kind of dream did she have?
この実験の夢を見て、私なかなか寝れなくて、藤上さんに内容と違う寝言言ってたよって起こされて、ちゃんとしてって言われて、ほんまに役に立てませんでした。そしたら目が覚めました。
She'd been dreaming about doing this experiment and woke up after being scolded by her usually kind upper classmate. It was quite different from the dream she wanted.
キング&プリンスのことを考えたにもかかわらず出たってことは、やっぱり心のどこかで心配だなとか、うまくやりますようにとかっていうのが今日の彼女のメインの思いだったのかもしれないなと思って、まさに夢と意識っていうところの関係性が見れて面白かったです。
Trying to control your own dreams seems quite difficult, but I really respect the efforts of those researchers.
Me too. Since the experiment lasts for 7 hours during the night, the observers also have to take a nap. Sometimes they conduct this experiment 4 days a week.
Well, that's dedication. Do they repeat the experiment many times over the 7 hours?
Yes, there can be at least 3 to 4 REM cycles each night. So Ogawa and her colleagues repeat this experiment each time.
And what kind of data did they obtain from this experiment?
Well, take a look at this. Using data on 65 dreams reported from 11 university students, this graph illustrates the different kinds of dreams they had. The left side of the graph depicts dreams related to sleep experiment.
It looks like it's easy to dream about something that's really on your mind at the time.
That's what the researchers think also. On the other hand, we can also see there were plenty of dreams that are part of everyday life, but had nothing to do with the experiment. These involved friends and family or complete strangers.
I see.
Ogawa thinks that dreams do mean something, such as when a student realizes they are under pressure to do their best for this experiment, or even when they have a dream that they never expected. She considers dreams as sort of a mirror that allows a person to see their self in a new way.
That's an interesting idea.
It is. By the way, Tina, Do you always remember your dreams?
Well, sometimes I do, but not always.
Me too. Even though we may not recall our dreams, we definitely do have dreams every night. With 3 or 4 REM cycles a night, we're dreaming at least that many times.
So why are dreams so easy to forget? Let's look at research seeking clues to this mystery.
Why are dreams easy to forget? A paper was published on the latest research that offers some important clues. It described a mechanism that erases memories during REM sleep. MCH neurons play a key role. What exactly are they? The author of this paper was Dr. Akihiro Yamanaka at Nagoya University.
これが視床下部に存在する MCH 神経になります。
MCH neurons can be seen glowing bright green.
MCH 神経というのは摂食行動に関わる神経で、お腹が空いた時に活性化されてお腹が空いた食欲を調節する神経というふうに考えられています。
However, in 2009, it was discovered that MCH neurons are active even during sleep, which has nothing to do with eating, and Yamanaka began to pursue the mystery. About 65% of MCH neurons were found to be activated during REM sleep. Furthermore, they were found to be connected to the hippocampus, which controls memory in the brain.
食欲と、記憶というのはこれまではそれぞれの領域だけの研究が多かったんですけれども、私としても非常にびっくりしたということになります。
What are the memory-related MCH neurons doing during sleep? To investigate this, Yamanaka used one of the latest techniques to control the cranial nerves with light. It's called optogenetics. An optical fiber is inserted into a mouse's brain to illuminate genetically engineered neurons. This enables the function of a cell to be turned on and off like a switch. Using this technique, the activity of MCH neurons can be stopped and their effect on memory can be investigated. That led Yamanaka to conduct an experiment. First, a mouse is shown a toy banana for 10 minutes and then it sleeps for 90 minutes. The memory of the mouse is examined after it wakes up. Mice are very curious about objects they see for the first time and try to inspect them. However, they lose interest in familiar objects they remember and no longer approach them. In the experiment, researchers observe how close the mouse gets to the toy banana it saw before sleeping. If it doesn't get close, it probably remembers the banana, while if it does get close, it likely forgot. This is a normal mouse in which the MCH neurons are, so to speak, on. After seeing the toy banana, it's induced to sleep. Upon waking up, it starts to show interest again, just like when it first saw the banana. By charting out the time it spends, we see that the mouse is constantly getting closer to the banana. This indicates it forgot the banana while it was sleeping. So what happens when optogenetics is used to stop the activity of MCH neurons? After charting out the time it spends, we see that the mouse is hardly ever close to the toy banana. It remembers the banana. In other words, the memory never faded. These experiments showed that MCH neurons actively erase memory during REM sleep. Could this be one part of the mechanism that causes us to forget dreams? Yamanaka is continuing his research.
So we're one step closer to understanding the mechanism of forgetting dreams.
Yes, REM sleep happens frequently in the morning hours. Having many dreams as well as a mechanism to erase memory may be a clue as to why we struggle to remember dreams.
You know, I've also heard a theory that sleep enhances memory. Wouldn't this be the exact opposite idea?
Well, remember there's also non-REM sleep. Non-REM sleep is related to memory retention, while REM sleep may play a role in erasing memory. Nevertheless, it hasn't been fully explained yet.
Though it's hard to grasp the true nature of dreams, the power of science is now enabling research that may allow us to peer into others' dreams.
Dr. Yukiyasu Kamitani has been conducting this surprising research. Kamitani uses fMRI to peer into what the brain is seeing. Analyzing the blood flow in the brain when a person is looking at an image is said to tell us what they're looking at. Here's the procedure. Various images are shown to the subject inside the fMRI. Meanwhile, changes in the brain are recorded in detail. The blood flow in the part of the brain that controls vision is calculated with millimeter accuracy. The pattern is then analyzed by AI. If AI learning progresses, we'll be able to understand the figure a person is seeing just from blood flow in the brain. Simple figures were used at first. Then, even a figure the subject saw for the first time could be read quite accurately. Furthermore, in 2017, even when a complex image, such as an animal's face, was shown for the first time, the AI was able to reproduce it with considerable accuracy.
できた時は、僕も最初信じられなくて、いろいろ何か間違いの可能性とかね、今広くみんなに使ってもらうようになっています。
With this technology, we may be able to see the contents of dreams. Here are the results of an experiment trying to do just that. These ambiguous shapes are the world's first images taken from a sleeping brain.
我々の方法まだまだが不正確なんですけれども、その精度が上がれば、この画像を見ることによって本人も覚えていないような夢の内容が解読できるんじゃないかなと思っています。
That's incredible.
Yes, and scary. Dreams may no longer be just private thoughts in our head. Your dreams may be stolen in the future.
That sounds like a science fiction movie.
It does. Before, we could only analyze a dream to the extent that a person remembered it. It's quite a feat to be able to observe the contents while the person is dreaming.
I could see how that would be useful in solving the mystery of dreams.
We not only see things in our dreams, but also experience sounds and smells. I hope those aspects can also be studied under dream research.
Yes, if that becomes possible, dream research will make great progress.
It will. And incidentally, Dr. Kamitani has an interesting take on dreams.
人の胎児では、多くの時間、その24時間中の多くの時間をレム睡眠に費やしているというふうに言われています。その時に、夢を見ているかどうかはわからないんですけれども、何か原初的な、意識体験みたいなのがそこで生じているのかもしれません。で、それが生まれ落ちてから外界と接することでまたそれが変化していくみたいな。で、そう考えると、我々のその普段の夢っていうのの見方も変わってくると思うんですよね。それ単にその起きてる時のことをちょっと思い出しているとかですね、 学習に役立ってるとかじゃなくて、それが意識とか心の大元であって、それがその起きてる経験によってちょっとずつ変わっていくというような見方もできるかもしれません。
So his theory is that dreams may relate to our very essence as humans. It's an interesting concept.
It sure is.
Now, up next is J Innovators with Michelle.
We visited Chikushino City, Fukuoka Prefecture, which is famous for its hot springs. Hi, I'm Michelle. Today we'll focus our attention on soy sauce, an ingredient essential to Japanese cuisine. The Takumi we'll meet today has discovered from soy sauce manufacturing a chemical component that's attracting attention as a high-end beauty ingredient. Let's go meet him. Konnichiwa, 山本ミシェルです。
どうもこんにちは。福岡県醤油醸造組合の植木と申します。よろしくお願いします。
よろしくお願いいたします。Today's Takumi or innovator is Tatsuro Ueki. Every day he's engaged in research to develop better soy sauce. Soy sauce is essential to Japanese cuisine, but today we'll focus on what remains after brewing it.
こちらが醤油かすになります。
醤油かす、
はい、
この袋に入ってるんですか？
この袋に入ってます。こんな感じですね。
ああ、すごいパラパラ、ふわふわですね、パラパラして。These leftovers from brewing are known as soy sauce lees. In Fukuoka Prefecture, there are about 1,000 tons of them per year. The Takumi was looking for a way to make use of them.
この醤油かすの中にですね、実はこういった成分が入っているというのが分かりました。
これは何ですか？なんか白い粉ですね。
はい。で、これはセラミドになります。
セラミド？
はい。
Ceramides are lipids found in the top layers of skin. They help form the skin's barrier and retain moisture. Among these soy sauce lees, the Takumi found ceramides that are very similar to human-type ceramides. To make soy sauce, soybeans, flour, salt, and other ingredients are used. Then a mold culture known as koji is added in order to produce the soy sauce and its lees. During this process, the koji produces human-type ceramides. It's an unexpected ability of koji, which breaks down starch during soy sauce production.
これがはい。で、研究に使った麹菌なんですけども、これ一本一本がそれぞれ違う麹菌になります。
Koji is also used to make sake, miso, and Japanese hard liquor. The Takumi chose 20 types of koji to use in lab experiments. The Takumi inserted different koji into liquid containing nutrients. For 6 months, he observed how ceramides were made. And he finally succeeded in finding a koji that produced the largest amount of human-type ceramides.
で、最終的にこの麹菌を選んで実験に使いました。
なるほど。もうなんか麹菌っていうか、カビみたいになってるんですね。
まさにカビなんでカビそのものですね。
This is the koji strain that the Takumi found, which can produce many human-type ceramides. Now that he'd found the right koji, he needed a way to mass-produce ceramides. But even though he added nutrients to the koji, the human-type ceramides did not increase.
何かしらの刺激を与えてあげるということになるんですけれども、その刺激もストレスを与える。
ストレス？
ストレス。
菌にストレスですか？
ストレスを与える。
どういうことですか？
できるだけこうなんていうんだろう、たくさん増えようとする彼らはしてるんですけども、それに対して逆行するようなことをしてあげると。でそうすると自分たちも頑張らなくちゃいけないということで人型セラミドを作ってくれると。あんまり緩い環境にいると人間もそうですけども仕事してくれないんですね。
なるほど。
厳しい環境において仕事してもらうということになります。
The details are a trade secret, but he placed the molds under stress so that they could create more human-type ceramides. This graph shows the amount of ceramides made from koji with and without stress. Those without stress remained flat even after a long time. But the graph soared when those koji under stress were left for an extended period. The Takumi is still looking for a way to improve and mass-produce human-type ceramides.
そういうカスから人型セラミドを抽出して、そして商品開発までつなげるというふうなことが達成できています。しかしですね、さらに生産性という面でチャレンジをしないといけないところがあって、その一つの答えとして麹菌に積極的に作らせるというふうに取り組んでいるところです。
The Takumi says his human-type ceramides have already been commercialized, not only in cosmetics, but also in salad dressings. Now, today we looked at research on the mystery of dreams. Dr. Gathright, how would you wrap up today's program?
I find dreams really interesting. The mechanism for forgetting dreams is very interesting as well. And I was astounded by the research that allows AI to peer into a person's dream. I believe dreams are really powerful. If you think about it, Einstein's theory of relativity and some of the Beatles' best songs came in dreams. Many mysteries about dreams still remain, so I'll be eager to see what comes in the future.
Thank you very much. And that's all for this week's Science View.
Thank you for joining us, and we look forward to seeing you next time.